Hi everybody, welcome to Philosophy 1200. Today should be Friday, April 24th. Today's our last day of class, last day of lectures, and we're going to be going over replacement rules. Probably shortly after this video goes live, I'll be sending an email sort of outlining some of the information you need to know to prepare for the final exam. That will be a week from today. What I know so far is that it'll be a lot like the previous exam, meaning that you'll have all day to do it. It'll be largely open notes, so don't worry about having to memorize these rules or anything like that. So today we're just going to do some more of the replacement rules exercises, ones that will require or may require all of the rules we have at our disposal. And I just want to go over a couple of techniques that you need to keep in mind when doing these, because they can get a bit more complicated than normal. So yeah, we're just going to dive right into it. Alright, so here's the page that it comes from. It's still from that large problem set of exercises I posted on Blackboard, and then here's the specific problem. So I've set it up right here, got our rules right here, and we can just look at it. So we've got a conjunction here, we've got a disjunction up here. The first thing that jumps out to me is that we have this disjunction, and then both of the antecedents appear as both of the antecedents in these conditionals are disjunctions or disjuncts in this disjunction. So that tells us we could do the constructive dilemma, and we'd be able to bring down both of these conjunctions in the form of a disjunction. We could start thinking ahead about what we could do with that, but it's rare that a problem set would give you this sort of arrangement and not want you to do CD. So if it hands you a constructive dilemma on a silver platter, it's usually a good idea to take it. So that's what I do here in 4. Now I have the p's in the right place, and I think I can do a distribution. Again, I haven't sort of planned the problem out such that I know that that's the right thing to do. But again, this argument form is this statement form rather, is so uncommon that it's unlikely that it would appear in a proof and not need a distribution. So if we were to do the distribution on it, what we would do is we would knock the p to the outside, and then put a dot, and then S wedge L would be in parentheses. Alright, that's what we get via the distribution on 4. And now, looking at our conclusion, it seems pretty easy how to get that. We're just going to simplify 5, and we're done. So yeah, fairly simple. Required the constructive dilemma, required the distribution. Don't forget that if you wanted to, skip step 4 and just do the distribution on 4, that's fine, because I know what you're doing. But yeah, simple little problem there. Alright, this one. So we've got a conditional here, got a conditional here. Simple statement. That's our conclusion. So, let's think about this. One thing that jumps out to me about 1 is that we have, a conditional where both parts of the conditional are negated. That tells me maybe a transposition might be needed, especially since we need a unnegated Q in our conclusion. Another thing that jumps out to me is this guy, which looks almost exactly like the exportation form. So we could do an exportation on that. I think either one of these moves, either transposition here or an exportation here, I think either one leads us to the conclusion, but in completely different ways. So I forget which one I do in this PowerPoint, so we'll see. Alright, so I did what I think is easier, because transportation is a bit of a more complex rule. So I just took this. Transposition says you can flip their places, you just have to negate both of them. and technically this should be not P, then not Q, but I think I just cut out the double negation in that. So yeah, the transposition there, perfectly good. But what that enables now is a modus ponens on 3 and 4. So that's what I do there to get the Q, and since this is a disjunction, all I needed was either the Q or the S in order to be finished with my problem. So now I have the Q, so now I can just slap on the S. Boom, there you go. Problem's done. So as I said at the beginning, you know, we could have started by doing the transposition there, or we could have started by doing the exportation there. I don't think in this PowerPoint I did the exportation at all. So I just kind of like to show, you know, what it would look like. So here in 4, this is going to be like our alternative version. If I did the exportation on 2, that would be if P, then if R, then S. And then we could do modus ponens to get if R, then S. Actually, that doesn't get us our conclusion at all. Yeah, I think that's as far as we can get if we did the exportation on 2, because we have no way, from what I can tell, of you know, getting that S by itself, which we desperately need. So the exportation would have taken you that far. You know, that's enough to get you some partial points if you know, weren't able to find the conclusion the other way. So sorry, I was wrong about thinking that that's going to lead you to the conclusion. But it just shows how, you know, depending on which replacement rules you use, really changes the way that you can go about this proof. And if you were to have, you know, these lines included in this long proof, that's totally okay, so long as you end up with this, which apparently is only possible by doing the transposition on 4. Alright, now on to 6. We have if P then Q, both R and S, then P, R, and then our conclusion is if S then Q. Alright, so my first thought here is sort of similar to the last one, where that looks exactly like the argument or the statement form we need for exportation. And if we were to do exportation on that, that would free the R up and allow us to do modus ponens. So let's do that. So we do the exportation on 2, that shifts the parentheses over and turns this sign into a horseshoe. So now that would allow us to do modus ponens and get this on a line by itself. That's what we do there. Now I think the next move is doing a, wait, we can't do a hypothetical. Yeah, we can do a hypothetical syllogism on 5 and 1. If S then P, if P then Q, therefore if S then Q. That's what we do there, and we're done. So in this problem, it all depended on the exportation, which is a, you know, a tricky rule, but again, it's one of those rules that you're only going to need to use when you see a very specific form. You know, this statement form is not very common, and neither is this one. But when you see it, you know you can do something specific with it. All right, looking at number 7. Got this disjunction. We got a conditional right here. Conclusion's a simple statement. So I see 2 things here. First of all, looking at this, that's a negated disjunction. Whenever we see a negated disjunction, we should think about doing De Morgan's. Another thing that I see is this statement form looks exactly like this form of distribution. Again, that's rarely a coincidence. So, so I could do the De Morgan's on the consequent of 2, or I could just do the distribution on 1. I forget what I do in the next one, but I think that the distribution is a bit more fruitful. Well, okay. So I did the De Morgan's on 2. That never hurts anything. But then I think the next move, because the De Morgan's doesn't give me anything I can do immediately, it just might open up possibilities down the line. That's why it's never a bad thing to do with De Morgan's. But I think the next move in 4 is going to be a distribution. Yeah. So here, it becomes P or T and P or R. So now I have these two disjunctions, and I think the next move is going to be to split them up. Because whenever we see a conjunction, it's always good to split them up. Alright, that's what I got. So, just to make sure, I'm going to cross these out. So, take a look at this guy and this guy. We need not S. So if we did a modus tollens on either 2 or 3, that would give us our not S. Well, our consequent in 2 is not P or T. And here in 5 we have P or T. Well, if you're starting to get the hang of this, you'll know that the negation of not P or T is not P or T, which is equivalent to P or T. So the next move I'm going to do is I'm going to double negate 5. So that gives me my not P or T, and that allows me to do modus ponens and modus tollens. And just to point out, I can do modus tollens because remember, modus tollens is if P then Q, and this whole thing is my Q. Negation and all is my Q. So in this case, my Q only encompasses the first negation. So this second negation makes it not Q, which is exactly what we need for modus tollens. So that means in 8, I'd be allowed to bring down my not P, which is going to be the negation of S. And boom, that's what we do. So in this problem, we didn't need to do the De Morgan's at all. And I don't think that's a problem. You know, unless it's really confusing for you, I don't think, you know, if you see a De Morgan's like that, this is sort of the exception, not the rule. A De Morgan's will usually open up new possibilities for you. In this case, it didn't. But that's still, I still don't think that makes it a bad move most of the time. Right. Was that just a copy of the previous one? All right. All right. Here on 8, we've just got one single premise. We've got this in our conclusion. So a couple things jump to mind here. First of all, we've got a negated disjunction right here. That tells me that if we do De Morgan's, we'll get two negated conjuncts, and those are pretty useful. There's a lot of things we could do with that. Also over here, you know, the fact that these two are negated, for maybe this isn't the best reasoning, but that makes me think of transposition. So we could easily turn that into, you know, if S then P, or if not, oops. Well, I gave it away. But going back to this conclusion, that could easily be if not S, then not P, also known as if S then P. So we should keep that in mind. But as I spoiled by moving my hand flippantly, we can turn one into this conjunction via De Morgan's, and that's a good move because it gives us this conjunction. So now we can simplify both parts and see what we can do with that. But first, this is sort of an important thing to introduce a new technique. So I see right here that I'm not going to need this not Q for anything because it doesn't appear in my conclusion. I only have one premise, so I know that I'm not going to need that. I know that this not S is going to be important because it appears in my conclusion. So but it sort of presents a problem because I'm out of premises. I've already worked on one, and chances are, because I've only done a replacement rule, I can't make any more inferences about it. So when we have this like one premise argument, we need to be thinking, well, if it's valid and it's a one premise argument, what are the chances that the lone premise is just the conclusion stated in a logically equivalent form? So a lot of times when you're doing these proofs and you're sort of stuck, it's important to consider the other ways you can state your conclusion. And that's what I've done here. I've put this over to the side, and here I'm just considering what the alternative forms of my conclusion can be. So as I already said at the beginning, if I did transposition on my conclusion, we would get that. So that tells me, if I can manage to get this on a line by itself, then I have my conclusion, and I know the steps to get back to the original form, and I'm done. So another thing that I considered here, so this was the transposition, but the thing I considered here was the material implication. So the material implication, you turn a horseshoe into a wedge, and then you negate the antecedent. So that would give me not P or not S. So why would that be helpful? That would be helpful because I have not S already, and I can create a disjunction at any time via the addition rule. So if I have one part of this disjunction, I can just add the other part, and then what I'll do is I'll work backwards from this to get my conclusion. So I start by simplifying 2, like I should have done in the first place. Then I'm going to add my... Alright, I'm resuming this recording, so apologize if I lost my place.
I had a phone call.
Lori had a phone call. It was a long phone call. We work in a very small space. 1-bedroom apartments are a trap. Carrying on. Alright, so we added the not P to our not S here because we know that our conclusion is equivalent to this guy here. So now we pretty much have that disjunction. We just need to switch the places. So our next move is going to be a commutation. So that's what I do there. Now, in order to figure out that this was our logical equivalent statement, we needed to do material implication. So now we have to do material implication within the proof itself, and that'll get us a step closer to our conclusion. What's important to note is that, it's good to do replacement rules off on the side here, but just because you do it off on the side, don't forget to do it in the proof itself. It will not count unless you do it in the proof itself. So our next move is going to be to do material implication. Now I have these 3 tildes here, and that's just because I'm sort of doing it by the book. If you just want to call this, if not P then not S, you're totally good. But technically, when we do material implication on 5, we have to add a tilde, and then we turn the sign into a horseshoe. So my last move, which is sort of redundant, is going to be to do a double negation on 6, and that gives us our conclusion. So yeah, one very useful tip is to, look at your conclusion and consider, and right off on the side usually, consider what logically equivalent statements are equivalent to your conclusion. Think about what the other sort of statements you can end up with that will give you your conclusion. Very useful strategy. Alright, so for these last couple ones, I wanted to do some translations, and these are from page 452, problem 2. So we're just going to go through it. I'm going to lay out the symbols as they come, and I'm going to do parentheses after I lay out the symbols. So either dolphins or chimpanzees are sentient beings. So given this key, I would think that's going to be a straight disjunction, either D or C. Yep. So If chimpanzees can solve complex problems, then chimpanzees are sentient beings. So that's probably going to be if S, then C. Yep. If dolphins can learn a language, then dolphins are sentient beings. So that's going to be if L, then D. Alright, chimpanzees can solve complex problems, and dolphins can learn a language. So that's going to be a disjunction either S or L. Oh, sorry, S and L. I missed that. Alright, and now our conclusion, indicated by so. We must conclude, also a conclusion indicator, that both chimpanzees and dolphins are sentient beings. So that's going to be C and D. Yeah. So here we have a four-premise argument, very simple in the translation, but we'll see how the proof goes. So our next step is to put this in proof form. Again, if you translate this and you aren't super confident about it, draw a short truth table and see if it's valid. If it's valid, you're free to continue. If it's invalid, go back to the translation. Alright, so there it is in proof form, and now let's consider how to prove this. Well, I think our first move is going to be to simplify 4. Yeah, that's what we do here, and that just gives us some more options. We can now do modus ponens on 2 and 3. That's what we do in 7. We do it on 2. That gives us C. On 8, we do it on 3. That gives us D. And look at that. Now we can just conjoin these two and call it a day. And boom. So as we can see, I think this is true with a lot of these problems. With the translation exercises, the proofs usually aren't that complicated, especially if you translate them right. The hardest part is doing the translation and getting that right. So this is a good example. It throws a lot of premises at you, but once you get them all on the table, doing the proof itself isn't that difficult. Alright, so now here's another example. If there is a raging fire in the attic, then there is a constant supply of oxygen to the room. If there's a raging fire in the attic, then a window must have been left open. Thus, if there's a raging fire in the attic, then a window must have been left open, and there's a constant supply of oxygen in the room. So looking at this first statement, it looks like we're going to have if F, then O. Our second one, if there's a raging fire in the attic, so if F, then W. And finally, our conclusion, if there's a raging fire in the attic, so that's F. If F, then a window must have been left open and there is a constant supply of oxygen in the room. So that would be if F, then W and O. So that presents a question of where the parentheses go. Do they go around the F and the W, or do they go around the W and the O? I think that the correct answer is there, and I think the comma is a big indicator there. But also think about, as we've said previously, there being a raging fire in the attic requires two things. It requires the window being open, and it requires the constant supply of oxygen in the room. So, yeah, I think that's the right translation. Yeah. Alright, so there we got our translation. Now we have to put it into proof form. That's what we've done there. So now let's think about what to do with this. So, our premises don't give us a lot of options here. We have the same antecedent in both cases. So if we get F, we can go a lot of places. We can probably, if we get F by itself, we would probably be done based on this, but it doesn't look like we'll be able to get F by itself. So one thing I want to do now is think about our conclusion. So I'm going to draw my 4 dots, and over here I'm just going to draw some logical equivalent statements to our conclusion. So if we did implication, that would give us either not F or W and O. So that's an option. And that might be a good option because it looks like distribution, and we'd be able to distribute that, create two disjunctions out of it. So that's a contender. Furthermore, another thing we could do is maybe not W and O, then not F. So that one's the transposition. And that might be helpful because that gives us, if we were to De Morgan's on our antecedent here, we'd get what? Not W or not O, then not F. There's a lot of moving parts here, but that's an option. Trial and error is not a bad idea when you have a proof like this. I'm going to try to do the material implication, try to see what we can get from that. So let's see. So this is the first step. That's an equivalent statement for this. Now let's see another equivalent statement of this form via the distribution. So that would be not F or W and not F or O. So that's a logical equivalent statement to this, and that's a logical equivalent statement to this. So we're still in good shape here. But what does this all tell us? So this form, the post-distribution form, tells us that if we get both of these disjunctions by themselves, then we can conjoin them. And look at how each disjunct looks like our two premises here. So that should start, poking our brain a little bit and challenge us to think, well, are there logically equivalent statement forms for our two premises that are these disjunctions? And if we look closely, we'll see that if we do material implication on 1 and 2, we're going to get exactly what we need. So, this problem is difficult because it requires you thinking all these steps ahead. And, we haven't made a move yet. But we've already had to apply a lot of rules and sort of think strategically about what we're going to do. But I think this is probably a good thing. If we can do material implication on these two guys and then conjoin them, we'll have this. Then we'll do the material implication, then we'll do the distribution to get this guy, and then we'll do the material implication to get our conclusion. That's the plan. We're going to enact it. If it doesn't work out, we're going to try something new. All right. So this is just me doing what I did in that previous thing. So we do the implication on 1. That gives us this part. We do the implication on 2. That gives us this part. Now we can conjoin them. And that gives us this. And we've already stated that this statement is equivalent to this statement via distribution. So that's going to be our next move, to do the distribution in reverse. And that gives us that. Now we established that this guy is just a material implication of this guy. So our last move is going to be to do the implication. And that gives us not F, then both W and O. Again, if you just want to call this if F then both W and O, you're good. But doing my due diligence, I double negated it. So our last move technically is going to be to double negate to get rid of those tildes. And boom, that's what we do. So I think the biggest takeaway from today's lecture and some of these harder replacement rules proofs is that they will challenge you to consider the conclusion. If there aren't any obvious intuitive moves in your premises, before you start going willy-nilly with material implication and whatnot, and transposition and whatnot, think about what your conclusion is and what some alternative logically equivalent statement forms your conclusion is. If you do that and you do that correctly, you figure out what else you can get, and then you work backwards, that's how you can solve a lot of these proofs, and it'll be very useful on the exam and otherwise. So with that being said, that's the end of today's lecture, the end of the lectures for the year. I just want to say thank you all so much for being in my class. It's really been a pleasure. I don't know, the second time teaching a full semester in this class, and it's been a really good time for me. I really wish that our semester could have ended under better circumstances, but I really appreciate all the hard work you guys have done and your patience with me and the class. And I hope that your semester finishes really well, and that you guys, succeed in the rest of your education. So, thank you very much. Please talk to me as you're preparing for the exam, and yeah, I'll talk to you via text and email and otherwise. So I'll see you. Goodbye.